Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Welcome to Lesson 12, Solving Equations. Okay, this lesson starts with an opening exercise, so pause the video, see if you can answer these 4 questions, A, B, C, and D, and then unpause and see how you did. Okay, so it says to answer the following questions. A. Why should the equation x minus 1 times x plus 3 equals 17 plus x and x minus 1 times the quantity x plus 3 equal x plus 17 have the same solution set? Okay, so here's the reason. If I look at the right side, we have 17 plus x, and over here we have x plus 17. The x minus 1, x plus 3 are the same, so that is the commutative property. Okay, why should the equation x minus 1 times x plus 3 equals 17 plus x and x plus 3 times x minus 1 equals 17 plus x? So what changed here? The 17 plus x is the same on both sides. These are the same, but the x plus 1 is here, and the x plus 1 is second here, and the x plus 3 is first here, and the x plus 3 is second here. Well, again, that is the commutative property of multiplication, if you want to be more specific. Part C says, do you think the equation x minus 1 times x plus 3 equals 17 plus x and x minus 1 times x plus 3 plus 500 equals 517? Oops, let me undo that clone. Okay, so what happened here was they added 500 to the left and they added 500 to the right. So the answer to this question, we would say yes, 500 was added to both sides. So that is called the addition property of equality, if you need to know that. You do. Addition property of equality. What you do to one side, you do to the other. Okay. And then finally in part D, do you think the equation x minus 1 times x plus 3 equals 17 plus x and 3 times x minus 1 times x plus 3 equals 51 plus 3x? Okay, so what happened here? So if we look at this more closely, let me switch to blue. We have this 3. That was added to the left side, so I'm going to multiply this, so it would be the same as 3x minus 3 times x plus 3. So we're multiplying one of the factors by 3. Over on the other side, 51 times, or 17 times 3 is 51, and x times 3 is 3. So I multiplied both sides by 3, so therefore my answer to this question would be, do I think it would have the same solution? Well, the answer would also be yes, comma, space, because both sides were multiplied by 3. And that is the multiplication property of equality. So what you do to one side, you do to the other again. Okay, the next part is exercise 1. Again, it's an exercise, so you need to do this on your own. So pause the video, see if you can do it, come back, check your answers. Okay, so commutative property means order doesn't matter. So we have x squared minus 3x plus 4. And then over here we have 3 sets of parentheses. So what I would do is take x squared minus 3x plus 4, leave it as is, and say that equals, and just rearrange this. How about 5x plus 7, x minus 12. Okay? B, use the associative property to write an equation that has the same solution set as this. Okay, well, associative property is very similar to commutative property. What the associative property is moving parentheses though. So what I could do is say that x squared plus 3x. So I'm thinking about when I complete a square, I group my variable terms and do that, and then equals, and then I could do x plus 7 times x minus 12 and put parentheses around that. That would tell me to do these two first with an extra set of parentheses around. I didn't have two here either. Let me rewrite that. So what I would want to do here, let me change colors too to make it more clear what I'm doing. So I put a parentheses around the parentheses x plus 7 times x minus 12. Close those parentheses and then put the 5 outside. So I added parentheses here and I added parentheses here, which tells order of operations to do inside the parentheses first. Part C says, does this reasoning apply to the distributive property as well? And the answer is yes, it does.
Okay, page 2 brings us to exercise 2. Since they're exercises, you should probably pause the video, try these on your own, and then come back and see if you could do them. Okay, exercise 2 says to consider the equation x squared plus 1 equals 7 minus x. Verify that it has a solution set of negative 3 comma 2. Draw the solution set as a graph on the number line. So I'll do that first. So when you draw a solution set on a number line, all you do is take the solutions that are in the set and put a dot on the number line where they're located. So if I have a negative 3, then the solution would be graphed by putting a dot at negative 3. And then if I have a 2, then I'd put the solution graphed at 2. So that would be what the solution set looks like for this. Just two solutions that are integers, negative 3 and 2. Now we need to verify that these solutions are true. So what we do is take these and substitute them in for x. So I'll take that negative 3 and square it, add 1, and set it equal to 7 minus that negative 3. Negative 3 squared is 9, plus 1 is 10, and 7 minus negative 3, or 7 plus 3, is 10. 9 plus 1 equals 10, that is true. So I'm going to check the next one. If I substitute in 2 and square it and add 1, that has to equal 7 minus 2. 2 squared is 4, plus 1 equals 7 minus 2, which is 5. 4 plus 1 does equal 5, so that is true. Part B. Let's add 4 to both sides of the equation and consider the new equation. So what they have done is they've gone to this equation right here and added 4 to it. So if I add a 4 to the left side, 1 plus 4 is 5, so now I have x squared plus 5. If I add 4 to 7, then I get 11. So that's there. So we've added 4 to both sides. Now we need to verify again, are these two true? So negative 3 squared plus 5 has to equal 11 minus negative 3. Negative 3 squared is 9 plus 5 equals 11 minus negative 3 is plus 3. 11 plus 3 is 14. 9 plus 5 is 14. So that's checks. That's still true. Now I'm going to verify if 2 is true. So I'm just going to take 2 squared plus 5 equals 11 minus 5. No, 11 minus 2. Okay. 11 minus 2. So 2 squared is 4 plus 5 equals 11 minus 2, which is 9. Well, 4 plus 5 is 9. So this is also true still. So what that means is if I add 4 to both sides, that is the equation, addition equality. What you do to one side, you do to the other. And then part C. Let's now add x to both sides of the equation and consider the new equation. So now I'm taking x squared plus 5 and I'm adding x to it. So that is now right here. I'm taking 11 minus x, and I'm adding an x. Well, 11 minus x plus x, the x's cancel, and I'm just left with 11. And now we're going to check again. So it's going to be 2 squared. Actually, let me do the negative 3 first, stay in order. Negative 3 squared plus 5 plus negative 3 equals 11. Negative 3 squared is 9 plus 5 minus 3 equals 11. 9 plus 5 is 14. 14 minus 3 is 11. So this is still true. Now when I substitute in 2, I get 2 squared plus 5 plus 2 equals 11. 2 squared is 4 plus 5 plus 2 equals 11. 4 plus 5 is 9 plus 2 is 11. 11 equals 11, and that is still true. So adding a variable to both sides still makes the equation true. Okay, part D. So now we're going to take these two equations, or this equation, these two terms, and we're going to subtract 5 from both sides. Add a negative 5 to both sides of the equation and consider the new equation. So x squared plus 5 minus 5, the 5 will go away, and I'll just get x squared plus x. 11 minus 5 is 6. So we're going to try this again with 2 and negative 3. So negative 3 squared plus negative 3 equals 6. Negative 3 squared is 9, plus a negative means minus 3 equals 6. 6 equals 6, that is true. And then I choose to use 2. 2 squared plus 2 equals 6. 4 plus 2 equals 6. 6 definitely equals 6. So adding a negative number to both sides makes the equation still true. Now it says to multiply both sides by 1/6. Multiplying by 1/6 is the same as dividing by 6, so x squared plus x over 6 is right here, and 6 divided by 6 is 1. And now we're going to check again. So then we're going to take our negative 2, or negative 3, and it's going to look like this. Negative 3 squared plus negative 3 divided by 6 equals 1. Negative 3 squared is 9, minus 3 over 6 equals 1. Well, when I simplify this, 9 minus 3 is 6. 6 over 6 definitely equals 1. 1 equals 1. That is true. Do the same with the 2. So we're going to get 2 squared plus 2 divided by 6 equals 1. 2 squared is 4 plus 2 over 6 equals 1. Well, 4 plus 2 is 6 over 6 equals 1, and that is still true. Anything divided by itself is 1. Okay, now it says let's go back to part D. Part D. So we're going to take this equation and add 3x cubed to it. So it's 3x cubed plus x squared plus x. So it's x squared plus x plus 3x cubed. They put it at the end. It doesn't matter. Commutative property of addition. And then 6 plus 3 plus x is right here. And we're going to check these two numbers again. So it's going to be negative 3 squared plus negative 3 plus 3 times negative 3 cubed equals 6 plus 3 times negative 3 cubed. Negative 3 squared is positive 9 minus 3 plus, and then I do the parentheses first. Negative 3 to the third power is negative 27 times a positive 3 is negative 81. So that's going to be 9 minus 3 minus 81. 9 minus 3 is 6. 6 minus 81 is negative 75. Equals 6 plus negative 3 cubed is negative 27. Negative 27 times 3 is negative 81. 6 minus 81 is negative 75. Okay, now we're going to do the same with the 2. So when I substitute in 2, I'm going to get 2 squared plus 2 plus 3 times 2 to the third power equals 6 plus 3 times 2 to the third power. 2 squared is 4, plus 2, plus 3 times 2 cubed, which is 8, equals 6 plus 3 times 8. Okay, 4 plus 2 is 6, but we multiply first, so I'll just leave those for now, plus 24. Always do your PEMDAS. Order of operations says to multiply before you add. Then add all of them up. 4 plus 2 is 6, plus 24 is 30, and that has to equal over here. So 6 plus 24, 6 plus 8 times 3 is 24, and 6 plus 24 is 30, and that is also true. Okay, page 3 brings us to exercise 3. It's an exercise, so pause the video, try this on your own, and then come back and we'll see how you did. Okay, so here we go. This is a fraction, which is also called a ratio. And this is a ratio. When you have two ratios equal to each other, it's called a proportion. To solve a proportion, we cross multiply. So I'm going to take 3 times 4 and equals 2r times 1. Okay, so 3 times 4 is 12 equals 2r times 1 is just 2r. And then to solve this, I divide both sides by 2. And when I do that, 2's cancel, and I get r equals, and 12 divided by 2 is 6. Okay, now it says to solve for s. S squared plus 5 equals 30. So what I'm going to do is, first I'll just write it. S squared plus 5 equals 30. Subtract 5 from both sides to get the s squared by itself. We're trying to isolate the variables, what that's called. 30 minus 5 is 25. And then to simplify that, we take the square root of both sides. In doing so, the square root of s squared is s. And the square root of 25 is either positive or negative 5. Don't forget that negative. Negative 5 times negative 5 is 25. Part C. Solve for y. 4y minus 3 equals 5y minus 8. First thing I want to do is get all my y's on one side. I don't like a negative variable, so to avoid that I always move the smaller one. Well, which is smaller, 4 or 5? 4 is, so I'm going to subtract 4y from both sides. Okay, minus 4y minus 4y. These will cancel, and I get negative 3 equals 5y minus 4y is y minus 8. Add 8 to both sides, and we're done. And we get y equals 5. Okay, and a lot of times when a student looks at an equation like this, their question is, does it matter what I do first? I said in the part C, I said I like to get my y's or my variables all on one side first. But that isn't what you have to do first. There's always different ways to do things. So we're going to do 4 different things here. And first, and we're going to see how the outcome is. So this group says subtract 3x from both sides first. Okay, that's our starting point. So we're taking an equation, 3x plus 4 equals 8x minus 16, solving for x using the given starting point. And then you do whatever you want after that. So given the starting point, first I'm going to rewrite the problem. 3x plus 4 equals 8x minus 16. And it tells me to subtract 3x from both sides. So I subtract 3x, subtract 3x. When I do that, I get the 3x's to cancel. 4 equals 5x minus 16. I'm now going to add 16 to both sides. 4 plus 16 is 20. And these 16's cancel, and I get 5x. Now I'm going to divide both sides by 5 to get the variable by itself. And I'm going to get x to equal 20 divided by 5, which is 4. Okay, now I'm going to do the same thing, same equation, 3x plus 4 equals 8x minus 16. Our starting point this time, though, is to subtract 4 from both sides. So if I do that, subtract 4 from both sides, I get 3x equals 8x minus 15. Okay? And then if I subtract 8x from both sides, I get negative 5x equals negative 15. Then if I divide both sides by negative 5, I'll get that x by itself. And I get x equals negative divided by negative is positive. 15 divided by 5 is 3. Okay, made a mistake there. I was supposed to get the same answer, and now I see what I did. I apologize for that, but I'm going to go back up here to my mistake. I need to watch my signs more closely. All right. I said negative 11 minus 4. This isn't an 11, it's a 16. 16. Negative 16 minus 4 is negative 20. All right. Then I'm going to subtract 8x like I did before from both sides, and I get negative 11x equals, there I am again. It's not 11. 3 is not negative. 3 minus 8 is negative 5x equals, these cancel, negative 20. Divide both sides by negative 5. These cancel, and I get x equals negative divided by negative is positive. 20 divided by 5 is 4. Okay, same answer. Now we're going to take the same equation. 3x plus 4 equals 8x minus 16. Subtract 8x from both sides first. So here we subtracted 3x, here we subtracted 4. Now we're going to subtract the 8x first. 3x minus 8x is negative 5x plus 4 equals negative 16. Subtract 4 from both sides, and I'm going to get negative 5x equals negative 20. Divide by negative 5, and I get x equals 4. Okay, and then finally we're going to do it one more time. 3x plus 4 equals 8x minus 16. I'm going to add 16 to both sides first. So I'm going to move this 16 over to the other side, and I'm going to get 3x plus 20 equals 8. X. Then I'm going to subtract 3x from both sides. Get all my x's on one side. These cancel, and I get 20 equals 8x minus 3x is 5x. Divide by 5, and the 5's cancel, and I get x equals 20 divided by 5, which is 4. So x equals 4, x equals 4, x equals 4, x equals 4. So no matter what we did first in this equation, we came up with the same answer. Okay, page 4 brings us to the closing. Consider the equation 3x squared plus x equals x minus 2 quantity times the quantity x plus 5 times x. It says to use the commutative property to create an equation with the same solution set. So the commutative property just means order doesn't matter, so I can rearrange this and call that x plus 3x squared equals, and then I can rearrange this. So I could put the middle parentheses first, x plus 5, then the first parentheses, x minus 2, followed by the x. So the commutative property just means to rearrange things. And so this is the commutative property of multiplication over here, and this is the commutative property of addition on the left. Okay, so part B says to use the results from part A and use the associative property to create an equation with the same solution set. Well, the associative property is parentheses move. So what I could do is put this in parentheses, like we were going to complete the square. And then I could put the first two terms in parentheses, like so. And since there are extra parentheses or move parentheses, that is the associative property. Part C says to use the results from part B to use a distributive property to create an equation with the same solution set. So the distributive property of the rule, there's nothing outside here, so that's not going to change. So it's still going to be parentheses x plus 3x squared equals, but I'm going to distribute this x here. So x, it would be x times x. Now let's see. It would look like this. I would take this x and multiply it by the first parentheses and the second parentheses. So what would that look like? Here, let me erase this. Using the distributive property. Okay, so before I want to distribute this, let's FOIL the inside. So that's going to give me x times x, which is x squared. X times negative 2 is a negative 2x. X, and then inside is 5 times x, so plus 5x. So there's my two middle terms. Add those up, and it's going to give me 3x. And then positive 5 times a negative 2 is negative 10. So this is what this will look like if I FOIL from the inside. Now I will distribute. So my answer is going to be x plus 3x squared equals x times x squared is x cubed plus 3x times x is 3x squared minus 10 times x, which is 10x. So there's my final answer. Now I use the results from part C. Add a number to both sides to the equation. So if I take this and say x plus, well, let's get rid of these parentheses now because we're not using them, x plus 3x squared plus 5 equals x cubed plus 3x squared minus 10x plus 5. So let me change the color of those. It said to add 5 to both sides, but I'll use a different color just so they stand out. I added 5 to both sides. Okay. Now using the results from part D, subtract a number from both sides of the equation. Okay, so it doesn't matter what number we use. So all we're going to do is take what we have now, x plus 3x squared plus 5, and I don't know, minus 2 equals x cubed plus 3x squared minus 10x plus 5 minus 2. Using the results from part E, multiply both sides of the equation by a number. So let's finish this though. Let's simplify it. That's going to give us x plus 3x squared. And plus 5 minus 2 is plus 3 equals x cubed plus 3x squared minus 10x, and 5 minus 2 is 3 again. Now I'm going to multiply both sides of the equation by a number. And how about 4? So if I multiply this by 4, it would look like so. I'm going to take 4, parentheses, x cubed plus 3x squared minus 10x plus 3, and distribute. Okay, 4 times x cubed is 4x cubed, plus 4 times 3x squared is 12x squared, minus 4 times 10 is 40x, plus 4 times 3 is 12. Okay, let me move this over. That's just the one side. And now I need to do the same to the other. I forgot the first piece. So I want to multiply this by 4. So I'll just do that up here and then bring it down here. 4 times x is 4x. 4 times 3x squared is 12x squared, plus 4 times 3 is 12. Okay, so there's our equation, distributing that 4 throughout. Use the results from part F, divide both sides of the equation by a number. Okay, well, let's make this easy, and we'll just divide them by 4. So if I take 4x plus 12x squared plus 12 and divide it by 4, then I'm going to get x plus 3x squared plus 3 equals. And then if I take 4x cubed plus 12x squared minus 10, oops, that's a 40, minus 40x plus 12, and divide that by 4, then I'm going to get, the 4's cancel, and I get x cubed plus 12 divided by 4 is 3x squared, minus 40 divided by 4 is 10x, plus 12 divided by 4 is 3. And what we're getting is what we had in E. So if you multiply something and then divide it by the same thing, you get back to what you started with, because they're inverse operations. And it says, what do all 7 equations have in common? Okay, they will have the same solution set. And it says to justify. Okay, I'm not going to take the time in this video to do all of these, but if you just solved these, I'll start up at the top and we'll solve that one. So if I have, let me make some space here and I'll copy it down. Okay, so we have the equation 3x squared plus x equals x minus 2 times x plus 5 times x. So I'm going to solve this. So on the left, I can factor out an x, and that would give me x times 3x plus 1. Over here, actually, I don't want to do that. Never mind. I could do that, but I don't want to. I'm just going to FOIL this, and that's going to be x times x, which is x squared. And then it's going to be x times 5, which is plus 5x. And then it's going to be minus 2 times plus 5, which is minus 10, all times x equals 3x squared plus x. Distribute, and I get 3x squared plus x equals x times x squared is x cubed plus 5x squared minus 10x. I'm going to subtract 3x squared from both sides. Okay, and I'm going to get x equals x cubed minus, or plus 2x squared minus 10x. I'm then going to subtract x. I'll do that down here. Subtract x from both sides. And that will give me 0 equals x cubed plus 2x squared minus 9x. Okay. Once I've done that, I now can factor out an x. So 0 equals x times x squared plus 2x minus 9. 0 equals x times, factor this, factors of 9 that add up to 2. Well, factors of 9 are 1 times 9, 3 times 3. None of those add up to 2, so I can't do that. I would have to use a different form to solve this. Okay. I'm just trying to factor this piece here. Okay, so I'm going to use the quadratic formula here for this. So let me change colors to purple. A is 1, 1x squared. B is 2, and C is negative 9. The quadratic formula says x equals negative b plus or minus the square root of b squared, which is 4, minus 4ac, all divided by 2a. Simplify that, I get negative 2 plus or minus the square root of 4, and then I have two negative signs here, that's going to be plus, and 9 times 4 times 1 is 36, all over 2. And that is going to simplify to negative 2 plus or minus the square root of 40, all over 2. Well, if I do a factor tree on 40, that's 2 times 20, and 20 is 2 times 10, and 10 is 2 times 5. To complete the square, or to find perfect squares, or to simplify a square root, I should say, you need two of the same. 2 times 2 is 4, the square root of 4 is 2, that would come outside. So that is going to equal negative 2 plus or minus 2 square root, and 2 and 5 are not pairs, so they go back together as 10. That's all divided by 2, and I can finally simplify that, and the 2's cancel, and I get negative 1 plus or minus 1 times the square root of 10. Okay, so that is 2 of my solutions, and my third solution is 0 because x 0 times this would be 0. So my answer would be x equals 0, or x equals negative 1 plus the square root of 10, or x equals negative 1 minus the square root of 10. Okay, so those are my 3 solutions. So I would have to go back and do every single one of these on this page to confirm that they're all equal by getting these 3 solutions. They could have chosen a better equation to do this, so we didn't have to have such a strange solution, an irrational solution. But anyhow, that's how you would do it. Okay, page 5 brings us to the end of lesson 12. Review the lesson summary and go to your problem set.